So example number 3, highlighting learning targets number 1.6c and 1.6d. What we're going to do with this particular example is we're going to use our properties of real numbers to solve our equation. In this case, we know it's an equation because I have an equal sign. So we have equal sign denotes equation. And as you may recall, we solve equations. And so we are going to work to solve this equation, and then we are going to justify our steps using the properties of real numbers as we work through this equation and solving, in this case, for the variable x. And so our first step using the order of operations would be to work with our parentheses or our grouping symbols. In this case, we cannot combine the like terms. We cannot combine these terms because they are not like terms. And so we go to our second step, which would be exponents. We have no exponents that are raised to a power above 1. So then we look at multiplication and division. There is nothing at the moment to multiply, so we need to look and see if we are working with division. Well, we do have, in this case, division by 2 on the left side of the equation. And so what I'm going to do is I'm going to put a line through my equal sign to show that the left side and the right side are separate from each other and that they must maintain equality at all times. So if I do something to the left side of the equation, I need to do that to the right side of the equation, the same operation with the same quantity or same value. So in this case, I have a 2 that is being divided. Well, now I need to look at inverse operations. So inverse operations are operations that undo the work of another operation. So in this case, the inverse of division is multiplication. So we're looking at inverse operations. And so our inverse operations, our inverse operation of division is multiplication. So to get rid of the 2 being divided, I need to multiply by 2 on that side of the equation. And what happens is that the 2 being divided by the 2 will cancel each other out. So the 2 and the 2 will cancel each other out because 2 divided by 2 is 1. And then our multiplication property, our identity property of multiplication tells us that anything multiplied by 1 is its value. And so that will leave us with 3x plus 5 on the left side. But I multiplied by 2 on the left side, so I need to multiply by 2 on the right side of the equation. And so what I used is the multiplicative property of equality to say I can multiply both sides by the same value, and in this case the same value that I multiplied by was the 2. So when I simplify that, I end up with 3x plus 5 is equal to 14. Once again, I'm trying to solve for x, which means that I need the x to be isolated or by itself. So the x is not yet by itself. I still cannot combine the 3x and the 5 as like terms. So now I need to remove the 5 using an inverse operation. I need to get the x by itself. And I'm going to work from the terms that are furthest away from my variable. Well, the term that's furthest away from my variable is the 5. And so I'm going to look at the 5. And by looking at the 5, I know that it's a plus 5. And if I want to remove the operation of addition, then I know that I can subtract. But if I subtract on the left side, I also have to subtract on the right side of the equation. And the property that allows me to do that is the subtraction property of equality. Now, anytime that you use an operation on both sides of an equal sign, you will be using the properties of equality. So when I simplify this further, I end up with 3x because 5 minus 5, or 5 plus a negative 5, is 0. And then 14 minus 5 is 9. And so I end up with 3x equals 9. 3 times x is multiplication. The inverse operation of multiplication is division, so I need to divide. And if I divide the left side by 3, I have to divide the right side by 3. And the property that allows me to do that is the division property of equality. And so I end up with 3 divided by 3. So 3 divided by 3 is 1. 1 times x is x. And so even included within this step, we have the identity property of multiplication. And then 9 divided by 3 is equal to 3. And so the final is that we have a solution because we have solved for the variable x. So you can see that we can justify each of our steps in solving this simple equation using our properties of equality.